All right, this video deals with 2.7, and so let's begin. We're going to find the complex zeros of a quadratic function. So finding the complex zeros of each of the following, and we're going to graph each function and label the intercepts. All right, so if you have f of x equals x squared minus 4, this is what the graph looks like. So the x-intercepts are going to be at plus or minus 2, comma 0. So to find those x-intercepts manually or algebraically, you have to set y equal to 0, and then 0 equals x squared minus 4, and then isolating the x using the square root method, you'll get the plus or minus 2 there. So if you look at part B, before I show you the graph up there, what would the x-intercepts be on that one? You thinking plus or minus 3 maybe? Well, let's see. Well, if you move the 9 over, set z of x equal to 0, that's 0. And then move the 9 over, it's negative 9 equals x squared. And so if you take the square root of a negative 9, oh, that's imaginary. So that's plus or minus 3i. So remember what happens when the solutions are complex. When they're complex, there are no x-intercepts. So it looks like that in this case. So the vertex is at 0, 9, and a couple of more points. You get 110, negative 110. If you notice, this graph is spanning away from the x-axis, meaning there are no x-intercepts. But we justified that by the square root method when we got the complex solutions. And so therefore there's no x-intercepts. Now, again, we've seen this before, the quadratic formula. In the complex number system, the solution of the quadratic equation, ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a does not equal 0, are given by this formula. So that's not new. But when that number inside the discriminant, b squared minus 4ac, is negative, when that's negative, the solutions are going to be complex. And so this example right here, we're going to find the complex zeros for each of the quadratic functions and graph them. Well, let's look at the graphs. Okay, so x squared plus 6x plus 2. Notice where the locations are of those x-intercepts. They're decimals. How do you get those? Well, you would set 0 equals to the x squared plus 6x plus 2, and then you would have to use the quadratic formula. And then once you use the quadratic formula, then it's just a matter of dropping the 0. Once you drop them in there and then simplify it and put it into a calculator, those where the decimals come about. Okay? What about g of x equals x squared minus 4x plus 8? Now, if you try the quadratic formula on that one, let's look at the discriminant. b squared minus 4ac. That's going to be 16 minus 4 times 1 times 8. The inside will end up being negative, so the discriminant is negative. And so therefore, since that is negative, there is no x-intercepts because it's complex. And let's look at it. There it is. Now, these vertices I keep referring to, you find those in our next section. I'm not going to be spend a whole lot of time in it in 2.3 and 2.7, but the next module on 2.5 and 2.4, 2.4 and 2.5 modules, those is where we learn how to find the vertex and to get more accurate on the graph. Most of the thing I want to get off of this section is to show you that when the solutions are complex, there are no x-intercepts, only when they're real. Okay? And this kind of nails it down right here, the character of the solutions of a quadratic equation. When the discriminant is positive, you'll get 2 unequal real solutions, which means you'll get 2 x-intercepts. When b squared minus 4ac equals 0, then that means you'll get a double root, just one repeated real root, which means 1 x-intercept, which basically means the vertex lies on the axis. And if it's negative, the third one, then you don't get any real solutions. They're complex, which equates to saying there are no x-intercepts for that quadratic function on the graph. Okay? And we did some of these in our last video, so you'll see these in a separate video when I did some lecture notes of determining the character here. So all you have to do is determine what b squared minus 4ac is on a, b, and c here on this example, and see if it's positive, negative, or equal to 0. So that's something we will address later. Okay, so that concludes 2.3 and 2.7. We got a total of 3 videos along with the lecture notes. So that should help you get to this one. And as always, if you have any questions, feel free to contact me, and you have a good day.